problem. Let's see how to solve this problem. You can simply plug f of 0, which is quite easy because t equals 0 will give you minus 10 plus 9i over I, whose value is known to us. Similarly, f of 1 is quite easy to calculate. The major challenge here is calculation of 2024. So clearly, if we plug t equals 2024, the calculation is going to be much clumsy. So is there a nice way of handling the situation? Find the slope of PQ and RQ, and then use tan theta equals m1 minus m2 y1 plus m1 m2, and that will give you the answer. But the calculation will be extremely lengthy. Here, instead of solving this problem, I am also trying to give you the position of all f of t as t varies. Okay, so let's see how we can solve this. So f of t is given. So f of 0 I have calculated, it's 9 plus 10i. Similarly, if you can see f of 1, just put t equals 1, and which will give you 9i into 1 minus I, which goes to 9 plus 9i. So we can clearly see that point P and point R is known to us. Point P is 9, 10 in the complex plane, and point R is 9. Okay, so what about point Q? 2024 calculation is not so cool. So we'll try some other method. So here is the idea. F of t I have written in the usual form, and now I want to find the locus of f of t. So I want to find the locus of this complex number f of t as t changes, and maybe we'll get some hint out of it. So as usual, we'll multiply with the conjugate t minus I, which I have done over here. And if you do the calculation, you'll get two parts. One x part is coming over here, and y part is coming like this. So this f of t can be written as x plus iy, where x is 10t square minus t plus 9 by t square plus 1, and y is 9t square minus t plus 10 by t square plus 1. Now it's easy to manipulate little bit. Seeing t plus t square plus 1 in denominator, we are tempted to bring t square plus 1 in numerator. So I added and subtracted by 10, which gives you this expression. You can do the same thing for y. You add and subtract by 9, and you'll get this expression. So that gives x equals 10 minus t plus 1 by t square plus 1, and y equals 9 plus 1 minus t by t square plus 1. Now there can be many ways of eliminating this. These two equations can be eliminated in many ways to find the locus of point x and y. One way is you can divide this equation, both expression. One way is you can divide this both expression, and then x minus 10 by y minus 9 is going to be 1 plus t by t minus 1, and use component of dividend window to find the value of t in terms of x, y. And then you can plug t in any one of the above equation, either x equals 10 minus something or y equals 9 plus something, which will give you the locus. Here what I have done is a bit smart way, because as you can see 10 and 9 average is 19 by 2. So let's try to work on that, because it differs by half and half in magnitude. And half, if I'll add in the RHS, it also brings symmetric term. So that was the motivation of bringing half into picture. So if I add half to it in RHS, we'll have x minus 19 by 2, and that gives you t square minus 2t minus 1 by 2 times t square plus 1. Similarly, if we'll take away half from y minus 9, you'll get y minus 19 by 2, and that gives, upon simple calculation, minus of t square plus 2t minus 1 by 2 times t square plus 1, and t square minus 1 minus 2t. So it feels like t square minus 1 minus 2t and t square minus 1 plus 2t is kind of some conjugate. So that might be a plus b whole square minus 4ab is a minus b whole square. So keeping that thing in brain, I was motivated to square both expressions. So x minus 19 by 2 whole square plus y minus 19 by 2 whole square. So this square plus this square, if we'll do calculation shows that we'll have t square minus 1 minus 2t and t square minus 1 plus 2t whole square, which gives a minus b into a plus b, so a square plus a plus b whole square, which is 2 times a square plus b square. And now interestingly, you can see like t square minus 1 whole square plus 4t square is nothing but t square plus 1 whole square. So this will get cancelled, and we are having 1. All the points represented by f of t for particular value of t will lie on this circle, centered at 19 by 2, 19 by 2, and radius 1 by root 2. But that doesn't solve the problem nicely, because now we know like point P and R is on the circle, but still some point is there, okay, 2023. So this is the point P corresponding to t equals 0. This point R is corresponding to t equals 1. And now we don't know whether t equals 2023 is going to be here or here or here or at which point. So let's say without calculation we can't, it feels that we'll not be able to solve. But here is a nice bypass way of doing this. What will happen if t is tending to infinity? So let's take the extreme case of parameter t, because t can be any real number. So when t is tending to infinity, in this case you can clearly see the occard of this term will be nothing in front of t. Similarly, I will almost be negligible in front of t. Basically, I am dividing by t if you want to find limit. But in a very loose sense, you can take t will get cancelled and we'll have 10 plus 9i. The actual way of evaluating the limit is you divide the expression by t, so which goes to 10 plus 9i minus 10 plus 9i whole by t by 1 plus I by t. And now you take t tends to infinity. So this guy will tends to 0, this will tends to 0, and the expression will tends to 10 plus 9i. So that's the takeaway. When t is tending to infinity, we'll get a point 10 comma 9. 10 plus 9i is the complex number. Of course, it's not a part of circle because infinity cannot be attained. So I have made it an open dot here, which shows like in the limiting case the point 9 comma which shows in a limiting case the point 10 comma 9 is on the circle, is trying to approach towards the circular circumference, but it's not the member of the circle society. Anyway, that makes our situation very healthy because the y coordinate of this point in the limiting case is still the same as the y coordinate of point r. So let's call that point to be s. So we know, like basically it feels as if on ps as a diameter this circle is drawn, right? Although s does not exist, but you can imagine as if on ps as a diameter this circle is drawn. And what's the center of this circle? Is clearly 9 plus 10 by 2 and 10 plus 9 by 2, which is 19 by 2 comma 19 by 2, which is evident from this case. Okay, and the radius of circle, so this distance or this distance is going to 1 by root 2. And now we have caught the problem because we know as we are moving from p to r, the parameter is changing from 0 to 1, so maybe 0.1, 0.2 and so on. And as we are moving from 1 to infinity, the parameter is changing via this way, we are going to 1 to infinity. So somewhere t equals 2023 will be here by mean value. So t equals 2023 will be somewhere in between. It can be at this place or this place, wherever it is. That kills the problem now because we wanted, let's say this point is q. Now we wanted the angle PQR, right? We wanted angle PQR. So what's angle PQR? You can clearly see the angle PQR is same as angle PSR. See, the angle PQR is same as angle PSR because they are made on the same arc PR. And now finding PSR is damn easy because PS as a diameter, this angle is 90 degree. And we know these two distances is equal. Just from the diagram, PR and RS is same, which is equal to nothing but 1. And hence the answer to this problem is theta equals pi by 4. So theta equals 45 degree, which translates to sin square theta equals 1 by 2. I hope you must have enjoyed this. And the takeaway was how cleverly we have escaped the calculation. Like it was better to directly put the value 2023 or maybe start with some generality and try to find tan theta. You will be lucky in this case because theta is pi by 4. So even that calculation will not be too traumatic. But the takeaway was even the locus problem can be asked here. And sometimes JEE main problem can be lengthy, and it was one of the best example for that. I hope you have enjoyed it. Thank you.